Now, let's look at a new topic, models with interaction term. This is very interesting and very exciting, actually. This is the first time that we're going to talk about it. First of all, what is interaction? Interaction, so for instance, if I have x1, x2, x3, interaction can be something like this. What's the interaction between x1 and x2? What's the interaction between x2 and x3? What's the interaction between x1 and x3, right? So these are called interaction terms, right? Then here's the key statements. We're going to say that the interaction terms allow for partial effect of an explanatory variable, let's say x1, depend on the level of another variable. So this another variable is key. And let's say x2 and vice versa. So you want to, when you compare this one to quadratic model, in the quadratic model, you had what? You had y equals beta 0 plus beta 1 x1 plus beta 2 x1 squared plus beta 3 x2 plus some error. When I take derivative with respect to x1, this derivative is going to be beta 1 plus 2 beta 2 x1. So the partial effect, the marginal effect of x1 on y depends on x1, the variable itself. But when I have this interaction, then the partial effect is going to depend on another variable. So let me write it down here. Let me write down the partial effect of y on x1 here, something like this. So what is it? Take derivative. Beta 1 plus, where else do I see x1? Here. Beta 3 x2. Do you see the difference? The partial effect of x1 on y depends on x2, right? So this is important because it comes from the intuition. You have a story. If you believe that the partial effect of your variable should depend on some other explanatory variable in the model, you have to add the interaction term between these two. So for instance, let's say my variable, we're going to look at it in more details in the next chapter, but this is the most simple and straightforward example. Imagine I believe that the level of wage depends, the partial effect of education on wage depends on race as well. So for instance, if it is black, if you're talking about black versus white versus ethnicity, and we're going to say if you believe that the partial effect of education on wage should be dependent on gender as well, gender, race, ethnicity, things like this, you have to add the interaction term between gender and education, between race and education, between ethnicity and education, and etc. Right? So, and we are going to revisit this example of wage and education and race in chapter 7, which we have a dummy variable. But here we're going to look at the partial effect of two variables, x1 and x2. Both of them are continuous. So let's look at an example here. Imagine we are regressing price on square feet, bedroom and square feet, bathroom. Okay. So why do you think that this setup is a good setup? Because originally you believe that the partial effect of number of bedrooms on price must depend on the square feet of the house as well. If you think that that's the case, and it makes sense, right? Think about it. Because maybe the higher the larger the square feet, this effect should be smaller, right? Or it should be higher. Again, it depends on your intuition. Maybe you think that it's higher, maybe you think that it's smaller. But either case, it really doesn't matter. As long as you think that that should depend on square feet, you put it in the model and see what the data is telling you. Okay, so that's what we're doing. You put the interaction of a square feet and bedroom in the model, and then see what the data suggests, if this number has been positive or negative. You want to see if the marginal effect of bedroom on price is going to be positively affected by a square or negatively affected by a square feet. Okay, so if I take derivative with respect to bedroom, I want to see what's the partial effect of bedroom with respect to price. So wherever I have bedroom, I have to, let's erase everything. So wherever I have bedroom, I take derivative. I have beta 2, okay? Then beta 3 is square feet. You see, The marginal effect of bedroom on price depends on some other variable, square feet. So we read it like this: the effective number of bedrooms depends on level of square footage as well. All right. Now, interaction effects complicate interpretation of parameters. And when it's, well, we did it on purpose because we believe that the effect of bedroom on price is not simply depends on bedroom or depends on nothing. Okay, it should depend on something else. And in this case, we believe that it depends on square feet. Now we have to interpret it slightly different, right? So beta 2, so if I ask you how to interpret beta 2, I would say that beta 2 is the marginal effect of bedroom on price only if square feet is 0, right? So do you think that this is a good interpretation? Usually we don't care about beta 2 alone. I care about this one. I care about the marginal effect of bedroom on price. So for instance, I want to see what's the marginal effect of bedroom on price, BD. I know that it's equal to beta 2 plus beta 3 square feet, right? And usually, instead of 0 for square feet, because if I plug 0, I get beta 2. So they say, okay, marginal effect of bedroom on price is beta 2. But usually, instead of 0, we put some meaningful numbers. So again, most of the time, we put the average, square average. And if I put the square average in the model, then we say this is the average partial effect of bedroom on price. Okay, so again, it's more meaningful to put some again meaningful numbers here. I can put Q1, I can use Q3, I can use average. These are better numbers to use rather than 0, right? Because you're not interested to see if the square feet is 0, then what's the marginal effect of bedroom on price? That's nonsense. We know the answer is beta 2, but that's nonsense. So we usually put the average here, square, and then we call it APE, average partial effect. We're going to look at the numerical example of APE, average partial effect, in the future slides. All right. Are we doing good? So let's look at a comprehensive example. So this is an example that we have everything, right? Look at that. We want to see what's the effect of attendance on final exam performance. And this is one of the most beautiful examples that you can relate. I think the students, myself as a student, I relate to this. And that's where the beauty of this having interaction term in the model is going to be clear to you. So let's go over this example. Imagine we want a model to explain the standardized outcome on final exam in terms of percentage class attendance, prior college GPA, and ACT score. Okay, but I can go ahead and say, okay, regress, my final exam score on attendance rate, college GPA, and ACT score, and be done with it. But we want to have some fun. We want to add some quadratic version. We want to add some interaction terms, and etc. So let's say this is our model. Okay, the model is let's regress. This is a standardized final score. This final exam score regressed on attendance rate, prior GPA, prior college GPA, ACT score, and now this is the part that we are going to have some fun. Add the GPA quadratic version as well, prior GPA quadratic. Add the ACT quadratic, and add the interaction between prior GPA and attendance rate. Okay. For each of them, we can have a story. Actually, we should have a story. Ex ante, before putting data into this model, we have a story. So let's explore a couple of them. So for instance, you believe that your prior GPA should be quadratic, right? So again, you think that if I want to look at the effect of prior GPA, it's something like this. Again, you might agree with this, you may not, right? But if you think that the effect of GPA, for higher level of GPA, the effect of that GPA on the score on the final exam is going to be higher, then this is a right setup compared to this one. So this is why we have GPA score. The same story for ACT. But what about this one? This is the fun one. Okay. So this means that, well, for instance, if you take derivative of, if you want to see what's the marginal effect of prior GPA on your final score, this interaction term is going to suggest that the marginal effect of your GPA, your prior college GPA, on your score depends on attendance rate as well. So this is the part that I think that you can relate. So let me give you a story. So imagine, yeah, the goal is to see what's the effect of your score, what's the effect of college GPA, I call it GPA, prior college GPA on your score. And now we see that this is something that depends on attendance rate. Attendance, how do I write it? Attendance rate. Depending on if it has a negative effect or positive effect, but we have a story. We say that if your attendance rate was low, so think of it this way. I want to see what is the marginal effect of GPA on a score, right? If you have a high GPA, then maybe the marginal effect is higher or lower. But we are exploring the idea that this effect must depend on attendance rate as well. Why? Because think of this scenario. Do you agree that we see some students that their attendance rate is very, very low, but their GPA, the prior GPA was very high? So these are super smart and super sharp students. I have had students like this, right? So he or she didn't show up for any of my classes, and he or she ended up getting an A. So this means that he lost 5% of the attendance rate in the class, but still he ended up getting a grade more than 93%. What does it mean? So it means that he was a super smart student, right? His GPA was super high and the attendance rate was low. So I need to control for this interaction between the two terms. I hope that you get the idea. And so that's why we mean that if you believe that the marginal effect of the GPA on a score should depend on something else, put something like this in the model. So that's the whole story. Okay. Now let's read through the rest of the, and then with having this set up, then throw some data at it and see what's the story. And we can interpret the story. The interpretation of the story is your job. I want you to get to be an expert on that. Okay, so we are interested in the effect of attendance on final exam score. So here we are interested in the effect of attendance on final exam score, not the GPA on. Again, you can think of it differently. So how do I do that? How do I quantify that? I take derivative with respect to attendance rate. And if I take derivative with respect to attendance, I have beta 1 and I have beta 6 multiplied GPA. So this is my derivative. Okay. The idea is that class attendance might have different effect for students who have performed differently in the past. So again, if you're super smart students, your GPA was high, maybe your class attendance is not going to be affect that super negatively compared to a person who has a lower previous GPA. Okay, so that's the idea. Now we are going to throw the data at this model and see what are the coefficients. So the one that we were interested in is this one. The coefficient turned out to be positive, right? So what this is, and this is not contradicting to our belief, right? We believe that if your prior GPA was high, then the marginal effect of attendance rate on the score is going to be higher, right? Because you were smart students and etc. Okay. So let's write this number. Let's look at the numbers for this regression, for this marginal effect. The marginal effect is going to be beta 1. Where is my beta 1? It's this number. So minus 0.0067 plus beta 6 prior GPA. Beta 6 is positive, so plus 0.0056 GPA. So this is my marginal effect. I call it marginal effect of attendance on score. Okay, now let's interpret that. First of all, this number is negative. So am I surprised? Attendance has negative effect on the final exam. What's going on? So we have to interpret it like this. Yes, attendance has a negative effect on final exam only if your GPA was 0. Now it makes more sense, right? So is it the right statement? Well, maybe if you're, well, again, we say no because GPA of 0 doesn't make sense. So we can be sure that this number cannot be negative, right? If your GPA is anything greater than 1, well, actually, Well, one point something, but we know that GPAs are definitely greater than 2. Because they're greater than 2, then this marginal effect is going to be positive, because 2 of these 0056 is greater than 0067. Okay, so I'm not worried about this, that the attendance has negative effect on final score. Done. So here's the answer. We must plug in some interesting values for GPA, right? So I can plug average GPA to obtain the partial effect. So the mean value of GPA in the sample is 2.59. And so if I plug 2.95 in this equation, so what do I get if I solve for that? The answer is 0.0078. So this is what we call average partial effect. Average partial effect of attendance rate on final exam score. Okay. What does this mean? This is interpretation. Again, I expect you to be able to, if I give you something like this, interpret it that way. So we say that because attendance rate is, well, you have to be careful about the units. So the attendance rate is, it's already come is a percentage, right? So then we interpret it like this. It means that 10 percentage point increase in attendance rate. So if I plug 10 here, will increase your final score by 0.078. I just simply multiplying this one by 10 from the mean of final exam score. Okay, where is this from the mean coming from? Because I plug the average here. This is the average partial effect. So the average partial effect tells me that what's the partial effect of attendance on final score from the average, from the points, from the number that you use here. If I use Q1, from the Q1. If I use Q3, from the Q3. If I use 0, from 0. Okay, so that's important about interpretation. All right, so let's look at the output in R, and then let's call it a day, because yeah, well, how many more slides we have? So our next class is going to be relatively a shorter one, so bear with me with this one. So let me finish this this slide, and then I'm gonna spend more time on this slide next class when I open everything in R and do things in R. But let's talk about this one. Okay, so how do we put the interaction term in R? So I already know how to put the quadratic version. It's I open close parenthesis x to the power of 2. So this is for quadratic. How do I put interaction term in? So for interaction term, let me zoom in a little bit. You see better. So this is how we add interaction, this red rectangle interaction term. So in R, you have to say, if I am putting x1 multiply x2, in R we write x1 column x2. Okay, so this is how we add the interaction term. See, there is these 2 dots, dot, dot. Then the rest of it is, simple, and as always with things in R. So let's regress this final exam score on attendance rate, prior GPA, ACT, GPA score, ACT score, and the interaction between attendance rate and GPA, the prior GPA. Data, attend. So this is something that I want you to do for your final project as well. So come up with some interesting interaction terms. And where should you start? You should start from the intuition. If you believe that the partial effect of one variable should depend on some other variable, then you use interaction term. And now let's look at the significancy. Attendance rate itself is not significant. Okay. Prior GPA is, ACT not significant, GPA score is. So it means that if I have GPA score is not a bad idea. And ACT score is, look at that. ACT itself is not significant, but ACT score is. So if I were the author, maybe I should have got rid of ACT score and see if what I get for ACT, if it turns out to be significant or not. And then look at the interaction term. Interaction term is not significant. Even though we had an interesting story for that, but it was not significant. Okay, constant, not significant. All right, what is the R score, adjusted R score? Not bad, 22%. Okay, so let's say you're doing your final project, or you're doing a real world project, or your thesis, or whatever. You have a very good and convincing story in mind. you were super pumped about this idea at, okay, attendance, well, GPA should have some effect on the marginal effect of attendance on your score. But the data is not your friend, is not supporting your idea. What should you do? Okay, so there are different ways that you can think about it. So first thing is, okay, you say, okay, I give up. Maybe my idea was not correct. I trust on the data. So this is one approach. And when you do that, you're going to get rid of this interaction term and then write your research like this. Okay, I was interested in this topic, but the data does not support that. But it seems that there is no evidence that supports this belief. So this is one way. Another way is that you say, okay, let's look at the sign. Is this sign something that you like, positive or negative? If the sign is okay, but the magnitude is not okay, you can, again, make more convincing stories. Say, okay, you know what? The sign is there. So it means that maybe if I increase the sample size, I can get more significant coefficient, right? So this is a second approach. You're excited about the sign, it's suggesting your idea, and then you hope that, because be careful, this is insignificant. So it means that maybe if you do another sample with the same size, you get a negative number. You shouldn't be super excited. But you have, you see the lights at the end of the tunnel, right? You say that, okay, maybe if I have the luxury to increase the sample size and this thing turns out to be significant and the sign is still positive, then bingo. So you have a good story, the data support that. And so these are different approaches that you can take when you're dealing with some inconsistency between your research question and what the data is suggesting. And the third one, you say, you know what? I don't like the data. I believe that this theory should have, the data should support this theory. I don't know what's going on here. So you say, maybe the data is biased, something like this. But you get the idea. As a researcher, I guess you are being capable of answering some very interesting questions by I don't know, by learning econometrics. And it becomes even more interesting when you do machine learning. Okay, I personally love this field. And so I hope that I could at least get you as excited as I am. Okay, now we are more professional. We are getting better and better in econometrics, so we can make some more interesting hypothesis tests as well. So let's say I want to see if the partial effect is significant, right? Going back to our previous slide, let's see, what was the partial effect? So let's say beta 1 plus beta 6 price GPA, right? And price GPA, I'm going to use the average number, 2.59. So this basically, I want to test if the partial effect of attendance rate on a score is significant, but not for any level of GPA, when the GPA is average. So basically, I'm testing if the average partial effect of attendance rate is significant. Average partial effect of attendance rate on final score is significant. So if you want to do something like that, so what is my null hypothesis? What was my average partial effect? Beta 1 plus average GPA multiplied beta 6, right? So this is a very interesting hypothesis. So the hypothesis is if the average partial effect of attendance rates on the GPA is significant or not. So if you want to test something like that, then we can use our friend linear hypothesis function. Okay, it's easy peasy, right? So you pass the regression is MRM. And then again, here, look at that. Look how I set up this one. This is my null hypothesis, right? I could have done it in a separate line, but I just wanted to show you that it's okay if you do it in the same line. So the null is going to be, look at that, instead of beta 1, do you remember we discussed it last time that R doesn't understand if you write beta 1 here, so you have to type the name of the explanatory variable. So beta 1 is attendance rate plus 2.5 multiple. Please do not forget this one, because if you do 2.5 and then attendance rate, R gets confused. This is a computer. You have to say multiply. And then beta 6. So let's see what is the name for our beta 6 in the previous slide. Beta 6, so here. In the original model, the beta 6 is the coefficient of prior GPA and attendance rate, the interaction term. So how do I write interaction term in R? Attendance rate, dot, dot, prior GPA. Okay, So I can do this seemingly difficult hypothesis test in just one line in R. This is my f-test, right? Restricted versus unrestricted model, and look at the p-value for f-test. Awesome. It's a small, less than 1%, so I'm happy. I reject the null. So I reject the null that look at what's the null? The null was average partial effect of attendance rates on score is 0. So I reject null that the average partial effect is 0. Okay. So let's go back here. Do you remember we saw this insignificant number and we get upset? We got upset here because it's not significant. But we were, we were smart. We said that, okay, I will not give up, even if it's not significant. I'm gonna make something about, at least make some statement about the average partial effect. And I'm gonna test that hypothesis. So I test if okay, maybe this was not significant at any level, but what about if I put the average GPA? So is it true that the average partial effect is not significant as well? The answer is no. I reject that. The average partial effect is not significant. And then you're super happy.